Welcome back to the deep dive. So today we're looking at a piece of engineering that you've probably never seen but have definitely benefited from. It's the Thor Broadcast H-Petit-4CH-RM. It's a bit of a mouthful. Our mission here is to take this really dense technical product sheet and, distill what it actually does. We want to understand how it lets a place like a sports bar get 4 different HD channels onto every single screen using old school TV cables.
No, me.
Okay, let's just get into it. This thing is basically a powerful video traffic controller for Coke systems. The core idea seems almost simple, really. It grabs 4 separate HDMI inputs.
Right, like from 4 different cable boxes or media players.
Exactly, and it converts them into, regular cable TV channels, the kind you just tune into.
And that's the magic trick. Think about a big restaurant or a bar. They might need sports on most screens, but maybe news on a few, and a digital menu on others.
That's a logistical nightmare to wire up individually.
It is. But this box just puts each feed on its own channel, like channel 70, 71, 72, and 73, so any TV connected to the building's coast can just tune in.
And what about the hardware itself? It's not just one big unit, is it?
No, and that's what's so fascinating about the design. It's modular. You have 4 individual encoder units, they call them petits.
Petits, okay.
And they all slot into one rack-mountable chassis. So you can start with just 1 or 2 channels and then, expand up to 12 if you need to.
So it's scalable. I see each one has its own NMS port.
Yeah, its own network management system port. So they're independent, which gives you a ton of control.
Okay, so it takes the inputs, and I see it's HDCP compliant, which is a big deal for things like Apple TV or protected content.
Oh, absolutely. That just means no black screens. It works.
But how does it push that signal through what could be really old, lossy wiring without it just turning to static? This is where the technical specs get interesting.
It's all about efficiency. It uses MPEG-2 video encoding. Now, that's not the newest format, but it's the one that pretty much every single TV out there understands perfectly.
So it's about compatibility.
Maximum compatibility. And it keeps the bitrate at around 19 megabits per second, which is kind of the sweet spot for high quality without totally overwhelming old Cocos cables.
That makes sense. But to push 4 streams to hundreds of screens, you'd need some serious power behind that signal, right?
You do. And that's probably the most impressive spec here. The RF output power is plus 24 dBmV.
Which, for those of us not in radio engineering, means?
It means it's incredibly powerful. It's like giving the signal a giant bullhorn. That's enough juice to feed hundreds of TVs a perfect HD picture, even after the signal has gone through tons of splitters.
But wait, wouldn't that much power just, blow out the signal for TVs that are on a shorter cable run?
Good question. And that's why it's fully adjustable. You can dial that power up or down across a really wide range from 70 to 100 dBm to perfectly match whatever your venue's specific wiring looks like.
And this seems to be a global product, too. I'm seeing ATSC, QAM, DVB-T.
Exactly. This is why that multi-standard support is so important. You can configure it for North American standards, European, Japanese, pretty much anywhere. One box can serve any market.
So it's future-proof, in a way.
Very. It's a huge selling point.
Okay, so we've got the signal there, but what about managing it all? We mentioned that NMS port. That's how you tell the system which input goes to which channel?
Correct. It's all managed remotely over an Ethernet connection with their software.
Yeah.
This is the real lifesaver for operators. You don't have to run to a server rack with a keyboard.
You can just log in from a laptop.
Log in, map your channels, set your power levels, name the service, everything. It bridges that modern digital source with the old analog system, but with modern centralized control.
So if we boil it all down, the core nugget here is this. The 4-Petit is this incredibly powerful bridge. It turns 4 modern digital streams into strong standard RF signals that can blanket huge venues using the simple coaxial wiring they already have.
That's it perfectly. And that leads me to a final thought for you to chew on. The whole world is moving towards IP streaming, everything over the internet.
Right.
Yet these massive critical distribution systems in stadiums, hospitals, and hotels still run on copper laid decades ago. So think about the engineering challenge there. Ensuring a perfect 1080p picture and a complex digital modulation standard can survive a journey over that old infrastructure. That process, managing that transition perfectly, is the invisible magic this kind of hardware pulls off every single day.